With climate change becoming an extremely important issue our planet is currently facing, our team built a climate change simulation modeler that can be customizable to any user, which is a unique feature that many climate visualizations do not have. So let's begin the demo. So the first page is a login page. You can either sign up if you don't have an account. I'm going to go ahead and log into my existing account. Okay, so once we log in, we've come to the home page, and our UI, we decide to go for a very simple UI with a page that you can just scroll through with all the features that we implemented with a navigation bar at the top. So the first model that we built was a heat map, and essentially what this does is it allows the user to see the distribution of CO2 emissions per capita amongst all the countries. So let's go ahead and select the year that we want to see. So let's look at the most recent year recorded, which is 2018, and we can view this map. So this renders a heat map of all the countries that are recorded, with the white ones being unrecorded countries. And we can go ahead and click on certain countries, and that'll pop up an alert that'll tell us the total millions of tons of CO2, as well as the population, which calculates, in turn, the tons of CO2 per capita for that country. So clearly we can see that the darker red countries equate to higher emissions of CO2. So that is the first part of our visualization, which is to see the distribution among the countries. So now we can scroll down to the next part, which is creating a predictive climate simulation. So this part is based on the idea that users want to see the projection of climate change, maybe until the year 2050, for example. However, they might want to enter in hypothetical situations. So for example, what will climate change look like in 2050 if I entered a certain point for 2025 or 2030? So let's start by creating a new simulation. We can call this USA Doomsday. And for that simulation, we can select the country that we want to simulate. So click on United States and create the simulation. Okay, so now we can actually add data points to the simulation. So let's go ahead and select the one we created. And if we go back to our heat map, we can check what was the previous value. The most recent value according to it is about 5.4 billion tons of CO2. So let's go ahead and say, because it's called USA Doomsday, let's say it's a really ugly trajectory. So let's go up to 5,800, add that data point for 2021. We can add a couple more, let's say 2023. And let's add one more data point. It's really killing the planet here. Okay, so we've added our data points. Let's go ahead and view our simulation so we can see the 3 data points that we've entered. And now we can go ahead and run our simulation to see what we get. Okay, so this is the CO2 emissions graph that we came up with. So this is the part of our modeling where we created a custom predictor for 3 different trajectories. So the blue dots are the historical data points, and then the yellow line is a linear model, the green line is an exponential model, and then the pink line is an LSTM model. So an LSTM model is a recurrent neural network, and the cool thing about LSTMs is that we can apply this to univariate time series data. So what this means in our situation is we simply have the years as well as the corresponding CO2 emissions in millions of tons. So we can simply apply an LSTM model, which will learn from previous patterns in the trajectory and come up with the next n data points in the sequence. And in our case, we want to predict until the year 2050, as well as take in the user input into account. So as you can see here, the red dots over here and here are the points that the user inputted. So as you can see, this follows a trajectory to 2050 to having about 6.6 billion tons of CO2 by then, which is not great. So let's go ahead and update our model, make it a little nicer. Let's say somehow we're able to reduce our CO2 emissions. So we can go to update data points, go back to 2021. Let's change that, make it lower. So let's say we can decrease our CO2 emissions. Update that one. And we go down to 5 billion. Let's say some cool technology comes out by then, we can go all the way down to 4 billion. Okay, so now we can view our simulation. These are the updated data points, and let's run that and see what we get. Okay, so this is looking a lot nicer. So as you can see, with our data points over here that are decreasing, we have an LSTM prediction which shows the decrease in CO2 emissions, but also a slight increase because it follows the same trajectory as our previous historical data, since it shows overall growth. But this definitely looks a lot nicer, which by the year 2050, we would have reached about 5 billion tons of CO2. Okay, so that kind of wraps up the CO2 emission visualization part. So the next functionality we created was the ability to share your simulations across users. So we kind of wanted to add like a social media kind of aspect to this. So for example, if I made this really cool simulation and I want to show the professor, look at this cool simulation I made. So we can go ahead and do that. So let's say we want to share this simulation. I'll share it with Abdul. You can go ahead and say share simulation. Okay, now if we log into Abdul's account, let's scroll all the way down, and here we can say view simulations that were shared to you. We see this one pop up. So let's see, it says simulation. And there we have the simulation that I shared. So yeah, that about wraps up our demo for this project. It was a really cool project to work on just because climate change is an extremely important issue nowadays. So yeah, thank you for listening to our presentation.